Hello students, welcome back. Let us continue with our chapter 8, Natural Language Processing. So far, we have covered topics which will help us to understand the context of whatever we are saying, as well as it will link two different sentences that we have already spoken, because uh, meaning of one sentence is dependent on another one. Today's topic is spell checking. We know what is the meaning of spell check, and we are using so many applications which help us to correct our spelling mistakes. For example, Microsoft Word, PowerPoint, Excel, all of these have spell checking algorithm. So how does it work? And how this spell check work? So let us see, and how can we implement this spell checking and make our system intelligent. So we have different algorithm which will help us to check for the spelling. Let's get going. Let's start with the introduction of spell check. It is a basic tool required for language processing. It is used for word processing, text recognition system, speech recognition, and generation. Right. So as we know that we are working with a system which will identify the speech that we are speaking in, right? So it will understand the voice. So speech recognition uh, is part of language processing, because the language in which we are speaking has to be understood by our system, right? So speech recognition as well as generation, because our system is responding to our speech in voice only, right? So it should be able to generate speech. So this is the basic tool that will help us to check spellings of our language. And this language can be any language apart from not just English, but it can be any other language as well. The process of spell check involves identifying words, non-words, and also suggestions and generation of correct words. Spell checking involves identifying words and suggesting the possible alternative for its correction. So as we know, whenever we are writing any word in Microsoft Word 2007, for example, if we have made any mistake in spelling, then it will show that mistake, and it will also give suggestions related to that wrong word, right? So it will give all possible alternative from its dictionary. So we can also add some words into the dictionary as well. So it will give suggestions on the basis of dictionary, and in which all the words have already stored, right? So spell checking is not just about identifying wrong words, but it is also including the suggestion of correct one, alternative one. For example, if one types Rama sat on the chair in MS Word 2007, the suggestion then it find that correct word is sat is missing, right? So here it is not sat, but it is sat. So in Microsoft Word 2007, it will give suggestion that here the wrong word is san, and we should replace it with sat. So it will give correct suggestion. But what if we try to type Rama sat on the chair? Then the error remains undetected, as word sap is spelled correctly as an isolated word, right? So the word SAP is not fitting there in that sentence. It is not giving any meaning. That Ram sat on the chair, it doesn't make any sense, right? But it won't detect any error because SAP is correct word. It is not grammatically wrong word, right? It is spelled very much correctly. That is why the error there will be there, and it will be undetected, right? So we should have some spell check algorithm, spell check tool that help us to identify such kind of errors as well, because the meaning here uh, is not correct, right? That there should be suggestion to show Rama sat on the chair. Okay, so before understanding how we can identify errors, let's consider types of error. Types of error in spelling checker. Error due to exit letter insertion, extra letter insertion. That is insertion of an extra letter while typing. For example, cooking is typed as cooking where there are two Ks, one of which is not necessary, it is incorrect. The extra K has been inserted within the word, right? So this is the error that is generated due to extra insertion of one letter, which is not required, which is not correct, right? Second one is error due to letter detection. Here, letter is missing in a word. For example, artificial, where I is not there, I is missing here, right? So it is possible that we make mistake by not inserting one particular letter which should be there, and due to which the error is generated. Third one is error due to letter substitution. We write one letter instead of another one, right? So the correct letter is replaced by wrong letter. This happens when a letter is typed in place of correct one. For example, in word artificial, where there is no T, it is not TIAL, right? The T letter has been wrongly substituted by C. So these are the errors that can be generated while typing something, right? Typing or saying something. Let's see classification of spelling errors. How can we classify these spelling errors? First one, it is typographic error. These are the errors caused due to mistake committed while typing. Right? So as the name suggests, typographic error, it is made just because of typing mistake. Whenever we are writing something in a hurry, right? When we are typing in speed, it is possible that it is just typing error, typing mistake. Then orthographic errors. These are the errors caused due to lack of comprehension of the concerned language on part of user. Because here the writer, whoever is writing, doesn't know the correct spelling of the word, and due to that error can be generated and it will be termed as orthographic error. Next is phonic error. These are the errors caused due to poor cognition on part of listener. For example, the word tough can be spelled as TUFF, tough, right? So phonic error, there are so many English words which can be spelled alternatively, like the example given here is tough, right? So the spelling of tough is very tough, we can say, right? So tough, TOUGH. But if we spell it properly, correctly, for is spelled as double F, right? So we can spell it that way also. So if we do not understand the language properly, then we can make this kind of errors, phonic errors, right? We are typing whatever we are listening because we do not know the correct spelling of that word. Okay, now let's see spell checking techniques. First one is non-word error detection. This process involves the detection of misspelled words or non-words. The word market is a known word. Its correct form being market. Techniques to detect known word errors are n-gram, analysis and dictionary lookup. Okay, so known word error detection means we have misspelled one word, and we have to identify, we have to detect that misspelled word or known word, right? So the process that will help us to identify such kind of misspelled words is known as known word error detection, right? So the example given here is of market, right? So market is wrong word. We have to spell it like market. So we have two techniques for that. First one is n-gram analysis and second one is dictionary lookup. Now let's look at these two techniques in detail. First one is n-gram analysis. N-gram technique make use of probabilities of occurrence of n-gram in the text to decide on the error in the word. In the context of spell checker, one tries to predict the next letter rather than words. So in n-gram technique, we are actually using the probability of occurrence of next letter, right? So here we are working on next letter, not next word. So whenever we are writing something, right, handwritten जो भी चीजें होती है, in that also we are trying to spell it in our mind, and we are trying to predict the next letter. So here also, whenever we are checking for correct spelling, we will try to predict the next letter rather than word. Right? We won't go for word, but we will try to identify the next letter which should be there. And this is how we will check for the correct spelling. This technique is used in handwritten or printed text recognition system, which is processed by optical character recognition OCR system. Right, so this kind of technique is used in OCR system. Now OCR system is something where we can click picture or we can give printed document and it will convert it into software, soft copy, right? So this technique will, this software, this system will use this technique, n-gram technique, n-gram analysis technique, where they will try to identify the next letter that should be there and then convert it into software form, soft copy form. The number 0, the alphabet O and D are quite often source of error in OCR, right? So we cannot distinguish between 0 and O whenever it is handwritten. If it is computer written, typed, then it is easy to identify, easy to distinguish between these two. But if it is handwritten, then it is difficult to distinguish between 0 and O, right? And D is somewhat similar to both of these, 0 and O, right? So the source of error here in OCR is such kind of similar looking characters. In OCR, common n-gram approach uses table to predict whether the sequence of character does exist within a Corpora and then flag an error, right? So in such kind of technique where OCR uses this n-gram approach, they will try to predict the sequence of character that should be there. If it is not in the same sequence that it should be, then it will flag an error, then it will generate an error, right? So in OCR यहाँ पे क्या करेंगे वो n-gram पूरा एक table बनाया हुआ है, and then they will try to predict the next character. They will form sequence of these characters, and then if it is not in the given sequence, they will flag an error. They will generate error. Next is dictionary lookup. Dictionary lookup involves the use of an efficient dictionary lookup coupled with pattern matching algorithm like hashing technique, finite state automata, etc. So in dictionary lookup, we will try to look at the dictionary. If we do not know the meaning of some word, or if we do not know how to spell that word, Then we will go to dictionary, check for that word, and then write the correct word. Similar pattern is used here in this algorithm as well, like hashing technique. Hashing technique, in that we create a hash table. Similar kind of technique is used here in dictionary lookup, where we will try to identify the word in the dictionary or in the table that we already have in the database, right? Okay. Second spell checking technique is isolated word error correction. This technique includes the minimum edit distance technique, key technique, rule-based method, n-gram probability, and neural network-based technique. This technique is a combination of three sub-problems, right? So isolated word error technique is correction of, it is a combination of more than one technique, right? So it includes minimum edit distance technique, key technique, n-gram technique, neural network technique. Now neural network technique will be covered in coming chapters, but basically isolated word technique will work on words, right? Different words will be identified and checked for its spelling. It is then subdivided into it is categorized into sub problems, three sub problems. First one is error detection, correction, word generation, and ranking the correct candidates, right? So first of all, it will identify the error that is there in your sentence. Then they will correct the word, whatever word is giving error, then they will correct that word, and then they will rank this corrected, upgraded word. They will give rank to it. Error detection uses either the dictionary or n-gram approach, right? So for detection, we have two methods, n-gram approach or dictionary lookup. So either of these can be used to detect error. The error, the correct word generation is found using a dictionary or by looking up in a pre-processed database of correct n-grams, right? So for correction, now we have found error, right? We have detected error. Now we have to correct that error. And for that, we already have dictionary. We have to look for that word into the dictionary. Once we find the correct word, then we have to just replace it, right? So we can look into dictionary, or we can do is look at the correct n-gram into the database that we already have, that we have already processed, right? So detection can also use dictionary and n-gram approach, right? So once we have detected error, we can correct it, and for that also we can look at the dictionary, or we can look into the database for the correct n-gram. Okay, next we have sounder algorithm. It is used as a simple phonic based spell checker. This algorithm makes use of rule found using the phonics of the language in question. It is developed by Robert Russell and Margaret Odell. Okay, so this is just a phonic based spell checker in which we have to in this algorithm, we have to feed our data, and then accordingly, this algorithm will give us the correctly detected, correctly spelled words, right? So we have rules for it. हमारे पास यहाँ पे 5 या 6 रूल्स है. उस रूल्स को फॉलो करके हम इस एल्गोरिथम का यूज करेंगे, एंड देन वी कैन स्पेल चेक for the word. The algorithm uses the code to check for the closest one. The code for the word consists of its first letter followed by three numbers that encodes the remaining consonants. Okay, so in this word, they will try to make code for the word. Right? जो भी word हमने यहाँ पे feed किया है, उस word के लिए they will try to make the code. How can we create this code? This code will be created by using first letter of that word and then three numbers which are representing the remaining consonants. Right? बाकी के जितने भी letters है उसको represent करने के लिए we have three numbers. So it will create basically 4 character code. One is a letter and other 3 are numbers. The letter is the first letter of your word and the numbers are created to represent it is encoded version of the remaining consonant of that word. These are the consonants that generate the same number, right? If the consonants are same, then the code will be the same. Let's see the steps of this algorithm. We have to remove punctuation mark and capitalize each letter in the word, right? So in a sentence, whatever letters we have to capitalize it and then remove all the punctuation marks, right? Full stop, question mark, comma, semicolon, all the punctuation marks has to be removed in the first step. Then we will retain the first letter of the word. Whatever the first letter, we will store it separately somewhere, right? So basically we are retaining that first letter. Then we will remove all the occurrences of A, E, I, O, U, all the vowels, plus H, W, and Y, right? If these letters are coming first in the word, then we will retain it. So in that case, we will follow the second step, right? So E, I, O, U and H, W, Y has to be removed if it is occurring in between the word, right? It is not the first letter, then it will be removed. If it is first letter of the word, then it will be retained, stored somewhere else. In that case, we will follow the second step. Next, we have to replace the letters by the members, right? Then we will remove the letters and their members are given, right? So we will see it in the table. We have members of each letter, right? So then all the letters will be removed by replaced by these numbers. If two or more adjacent letters not separated by vowels have to have the same numeric value, retain only one of them, right? So if we have two letters and it is repeated more than one time and these letters are adjacent to each other and they are not separated by vowels, then we will retain only one of them, only if they have same numeric value, right? So if we have two B consequently and these two B's are not separated by vowel, then we will retain only one of them, right? So only one B will be stored, another B will be discarded. Return the first 4 characters, pad with zeros if there are less than 4. So we have to retain, we have to store only 4 characters, first 4 characters of that word. Now, if the word is less than 4 letters, then the remaining letter will be padded with 0. For example, we have word of 3 letters. The 4th character will be padded 0. If we have two letter word, then the remaining 2 letters will be padded as 0, padded with 0, right? So these are the steps of our sounder algorithm, and this is the example. BFPV will be substituted with 1. So any occurrence of BFPV after first letter will be replaced by 1. C, G, J, K, S, X, Z. Any occurrence of this letter after first letter will be replaced by 2, right? Now the step here, the fifth step, which says that occurrence of one letter more than one time, two or more time, and it is not separated by vowel and they have same numeric value, we will retain only one of them. Which means that if one letter is G and beside G there is S, right? And G and S are not separated by any vowel, then we will retain only one of them. We can retain G because they have same numeric value. Okay. So this is our sounder algorithm. And here we finish our chapter 8. Thank you.